Today is lesson 3.2.1a. We're still in chapter 3 and we're going to take a look at solving inequalities with one variable. And so we're going to understand what an inequality is asking, and then we're going to be able to find the solution to inequalities graphically and algebraically. And we're going to be focusing on one-dimensional inequalities for this. So what does an inequality mean? So if we rewind just a little bit, we understand that a solution to an equation is just a value that makes it true. So, if you found x equals 5 and then you plugged that 5 back in and you verified it, if both sides of the equation equal each other, then you know that 5 is a solution. And we've found that there could be multiple solutions to the equation that it gives us. But now with an inequality, it's the same idea, but an inequality can represent a region of values. And what an inequality, or what we're actually doing with that, is we're comparing two sides. Instead of saying both sides are equal, we're now comparing and saying that one side of an inequality has more weight than the other, like one is greater than the other, or one is less than the other. And so the importance of this actually gives us that comparison ability. And you're going to see we're basically going to be doing the same process over and over again in this, but you're going to kind of see that there's going to be a generic theme. So let's look at this bare bones basic example, something that you've probably seen way back in elementary school. And so we're going to graphically represent the inequality. And I'm going to go through this very, very detailed. So if we wanted to look at this graphically, we look at our number line. And we need to visualize this number line. Now, if you remember, this inequality here has meaning. This means we're at 4, but I cannot include the value. And so because I cannot include the value, we represent that with an open circle. And so at 4, can't include it, open circle. Now, if I'm able to include the value, you would see an equal to symbol, so you'd see a line under that, and that represents a closed circle. And now, because we're comparing one side to the other, that means that a certain region is going to be true or a certain region is going to be false. And so what we need to do is we need to test. And so I can pick, imagine this like being like a barrier. I can pick any value on this side or any value on this side. And I'm going to start with values on this side. So I can test and I can plug in 3, or I can plug in 2, I can plug in 1, etc., etc. So I'm going to plug in 3, and I want to ask myself the question, is it true or false? And so is 3 less than 4? Well, the answer is true. Because 3 was true, it kind of represents every value on that side, and so we shade the side that's true. Now, one side is true, one side is going to be false because we're comparing those two sides. And so if we wanted to, let's say, what if we wanted to test this side instead? Well, 5, is that less than 4? No, it's not. False, which is why that side isn't shaded. And then we could assume, well, if that side's not shaded, then this side must be shaded, and we'd be able to do that one. But now we're going to move into the graphical interpretation of these inequalities. Now we're used to this. We're used to, and we've gone over this so far, where one function equals another function, and that is where our functions intersected. And we've spent time going through that graphically and examining where those functions intersect. But now we're going to be adding these two elements to it. And this first one is saying the solution to when my function is less than my second function, that's going to be the values in which my function here is below this function. And then the solution to this is where this function is now going to be above, because it's going to be greater than this function. Now that kind of seems weird, and we can kind of look at that and be like, but let's visualize it. Let's look at a few examples here. So this first one, this is what we've done. We said solve where does this function equal this function? Well, that's where they intersect. And so they intersect here at -1, and they intersect here at +1. But now this next example here says f of x is less than g of x. This is saying, where is my f function lower than my g function? Or, because my inequality is facing my g function, where is my g function higher than my f function? And so now we have to look at our image. And so if we're comparing the two, right, the darkened one is my g function, the lighter one is my f function, we can notice that like here, where they intersect, here, my g function is higher than my f. Higher. And so on every single value here, my g function's higher because that's going to move up. That keeps going down. And then on this side, same thing. Higher. Because it can't equal the value, open circle. And so your solution is going to be all the shaded value in which my g function is higher than my f function. And so let's write the solution. Well, it starts all the way over here from -infinity, goes all the way to -1. There's more, starts at 1, so union, and from 1 it goes on to infinity. Infinity always has parentheses, and because this is open circle, also this will have parentheses. So now let's look at number 3. This one says f of x is greater than or equal to g of x. So now this, my f function, we're looking to where that is larger. And so if we're looking here, my f function is larger. And so because it could equal to, it's going to be a solid circle. And then everywhere in between is where my f function is higher than my g function. And so that's going to be from -1 to 1. Let's look at another one. So where do these equal each other? Well, they equal here and here. So my answer is -1 and 2. Where is my g function higher than my f function? Well, my g function's the blue, my f is the red. So my g function's higher. And over here, it's higher. And so that's going to be from -infinity to 0, open circle, because there's no equal to, open circle again at 2, and it goes on to infinity. And then my last, where's my f function higher than my g function? That's here. So higher. And so that's going to be from -1 to 2. Now we're going to see a whole set of situations in which we're comparing one function to another. So like for example here, this represented a function, this represented a function, and what we were doing is we were comparing these two functions to each other. Now, let's look at these two different scenarios here. On the left scenario, I'm comparing this function, which is this parabola here, to -1. And if I were to say, well, where is my function smaller than my g function, right? And so where is my parabola below my g function? And that's going to be, well, it starts here, so open circle, it starts here, open circle, and it's shading in between, right? Because it's below, all of that's below there. Well, if I were to have this comparison, and I were to then, because I know that this is 1, right? It's less than -1 basically. If I were to add 1 both sides, well then this becomes 0. We're going to find out that it's actually much easier for us to be able to compare it to 0. And you're going to see why in a second. Because now it helps us look for solutions, the x-intercepts. That's one of the reasons. And so if you look at this situation here, because we're comparing it to 0, here's 0, open circle, the solution is the same. And so that's one of the reasons why we're actually comparing it to 0, is because in this instance here, there now are x-intercepts. But let's look at this one right here. Let's solve and graph the solution to this function right here. And so first thing we want to do is we want to find where they intersect. And if you notice, we are comparing it to 0. And so to find where they intersect, it's quadratic. And so a quadratic, right, because it's x squared. And so the way that we can solve a quadratic equation is either through factoring or through the quadratic formula. Well, the factors of 3 that add to 2, so that's how I'm going to get x plus 3 and x minus 1. My solutions set each equal to 0, and so I'm going to get -3 and +1. But all we need to do is worry about the number line. And so now I want to put these values on a number line. Now, even though I only wrote in -3 and +1, remember over here it's still -4, -5, -6. In between I have values like -2, -1, 0, and then over here I have 2, 3, 4, etc., etc. What I want to do is I want to test each region to see if it's true or false, just like I did in the very beginning. Right? Remember how I tested if a region was true or false? We're going to do that here. And so my solutions, because it says equal to, I can say solid circle, and then now I want to test. So pick a value over here, like -4. And so I plugged in that -4 into my function, and I want to see, is that going to be true or false? And so that turns to 16, -8, -3. I get 5 is greater than or equal to 0. That's true. And so because that's true, let's move on. Eventually I'm going to shade that, but we'll move on for now. Let's just find all the true or falses first. So now I'm going to pick a value in between here, which was 0. And so I'm going to plug in 0 here. And so doing that, I get 0 plus 0 minus 3. Is -3 greater than or equal to 0? It is not. That is false. And so I'll mark this as false. And then the last, I could pick a value over here, like 2, 3, 4, 5. I'm going to pick 2. And so 4 plus 4 is 8, minus 3 is 5. 5 is greater than or equal to 0. That's true. And so that region's true. We shade the regions that are true. And so that's going to be my answer here. So what I did here was the first thing I did is I found the values of intersection, which is basically the solution. So where would they intersect 0? And so to do that, factored it, found the solutions, and then step 2, I placed them on the number line. And so -3, 1, because it's equal to solid circle. And then step 3, I had to test each region to see if it represents a solution or not. And so that's why I tested a value on this, like -4, tested a value in between, like 0, tested a value over here, like 2, and then I put all of those values on the number line, and then you shade what's true. Now here is the second reason why comparing it to 0 is actually really, really important. When we compare it to 0, what we're actually doing is we're actually separating two types of numbers from each other. We're separating all the positive numbers and we're separating all the negative numbers. This may make it a little bit easier for us to be able to see or be able to find the solutions. So let's take my number line bar again. I have -3, I have +1. This statement right here, this is asking for all values that are greater than or equal to 0. So let's keep that in my mind real quick. Values that are greater than or equal to 0. And so what we're going to do instead is we're just going to find, is it going to be positive or negative? So if I test 4, or -4, and I simplify it, well, we already know it's going to be 5. Well, 5 is positive. So I'm going to say that that's positive. If I tested 0, we got negative, because it's negative 3. And if I tested 2, we get positive, because I got positive 5. Because this says greater than or equal to 0, well, what type of numbers are greater than or equal to 0? Positive numbers. And so my solution are all the positive values that I got. And so this may actually be an easier way for us to be able to find the solution. So I graphed the solution. Now we have to solve it. And so solving the solution, it's going to be from negative infinity all the way to negative 3, union from 1 all the way to infinity. And then if we wanted to look at this graphically, remember where is my function above 0? And so my function's above 0 here and on this side. And so that's what it looks like if we were to look at it with Desmos. All right, let's look at our next example. So same idea, the first step, I need to find the solutions and place it on the number line. So once again, this is a quadratic equation. So I want to bring everything to one side, so I'm going to subtract the 4x. And so I'm going to get x squared minus 4x plus 4 is less than or equal to 0. Finding the solutions to that looks like that'll factor into x minus 2 times x minus 2. So my solution is 2. So placing that on a number line, we have that value there. And so now I want to test each region. So testing each region, first, remember this is a number line. So over here I have 1, 0, negative 1, etc., etc. Over here I have 3, 4, 5, 6, 7. And so testing that, let's test in 0. 0 seems like a pretty easy value. So if I plug in 0, it's 0 plus 4. So that gives me 4 is less than or equal to 0. Well, that's false. On this side, I'll test 3. So 9, negative 12, 4. That side, I also get false. Huh. Well, that's weird. Let's try the positive negative way. Let's see what happens. Let's see if anything happens different. Okay, so here's my number line again. There's the solution, right? Because it equals the value, so it's equal to, so that's why I have that. And so now testing each region. Well, on this side, if I plugged in 0, I got positive 4. And so it's positive. Well, on this side, let's test 3. 3, I got a positive 1. Well, that's positive. Well, this value that I had, this statement here that's being compared to 0, those are numbers that are less than or equal to 0. Well, what kind of numbers are less than or equal to 0? Negative numbers. Well, I don't have any negative numbers here, so I can't shade anything. Well, at least that's consistent here. So what would be my answer? The only thing that's shaded in, which is that dot. So x equals 2. That's the only thing that represents my answer. And let's take a look. So it's saying, where is this function less than or equal to 0? Well, the graph is nowhere near below 0, but that's the only point in which it actually touches 0. And so that's why my value is 2. Looking at one more here. So it's already being compared to 0, which is good. So finding the solutions. Looks like I can do the square roots method. So subtract 1 on both sides, square root. Oh no. But I get imaginary values. Well, then what does that mean? Well, it just means that there's no value that I can place on a number line because they're not any real solutions. Which just means there's no boundary points. It's just this number line with no little open circle or closed circles. And so that technically means it's just one value that I need to try out. So pick any value. Like 0. Well, if I plug 0 in there, 0 squared plus 1, I get 1 is less than 0. That's false. So everything here is false, which means there's no solution. Well, don't believe me? Let's look at the graph. This is saying, where is this function less than 0? Or where is this function below 0? Nowhere is that function below 0, which is why it is no solution. To close this lesson, what did we learn today? Well, we talked about inequalities. And essentially, an inequality could represent a region of solutions. And the different ways we compared them is we compared them with functions, and we saw where does one function above or below each other. And then we also solved them algebraically. And then one of the things that I said that it's good to visualize inequalities is always comparing it towards 0. So once we compare our function to 0, it's much more easy for us to not only be able to solve algebraically, but then also if we wanted to do the sign chart with the positive and negatives, instead of actually finding what that value is, all we have to do is just say, is it positive or is it negative? And then we can determine if the region represents true or false, and then we can shade it to find our answer. Well, this does conclude our lesson. If you have any other questions, please leave them in the comments.